We can also use the slide method to factor trinomials when our leading coefficient is not 1. So we'll start the same way. I begin always by looking for a GCF, a greatest common factor. For this problem, I don't have a GCF other than 1, so we don't need to factor anything out at the beginning. I'm going to go ahead and identify my A, B, and C. My A, my leading coefficient, is 6. The coefficient on X is 1. And C, my constant term, is negative 15. From here, I'll multiply A and C. So that would be 6 times negative 15, which would give me negative 90. And I want factors of negative 90 that add to 1. This would be negative 9 times 10. If you don't pick out those factors immediately, remember you can always make a factor list until you find the factors that will add to your B term. So my factors that I want here are negative 9 and 10. Now remember, I place these numbers, these factors from my list that I'm choosing, directly into factored form. What we didn't see when our leading coefficient was 1 is that we actually keep our A term at the front of each factor. So instead of starting each factor with x, since I have a 6 in front of my x squared term, I start each factor with 6x. And then I finish the factors with the numbers I've chosen here. So that's minus 9 and plus 10. And then our last step to slide method is to divide by A. Dividing by A is important here because if I were to distribute exactly as I have this problem right now, I would end up with 36x squared. And that's clearly going to be an extra factor of 6. So we need to divide out that extra factor of 6. That extra factor of 6 may come completely from one of the factors I have on top here, or it may come partly from this factor and partly from this factor. For this particular example, I have a GCF of this factor equal to 3. I can divide 3 out of 6 and 9. So if I divide that out, I'm left with 2x minus 3. And then for our second factor, we have a GCF of 2, which I can divide out. That would leave me with 3x plus 5. So factor your GCFs out of the factors you have here. So this is gone. It's now factored into this. This is gone, factored into this. And then that 3 and the 2 will reduce the 6 on the bottom because 6 we know is 3 times 2. So this 3 and that 3 reduce down to 1. This 2 and that 2 reduce each other down to 1. And we're left with 2x minus 3 times 3x plus 5. We'll look at one more example of this. We'll hop down to problem 10 down here. No GCF for my terms here, so I'm going to start by multiplying A and C. So that would be 12 times negative 7, which would give me negative 84. The factors of negative 84 that add to negative 25 would be 3 and negative 28. Again, for this one, you probably would need to make a factor list. So then I'm going to take 3 and 28 and put them directly into factors. My factors will start off 12v, so 12v plus 3, and 12v minus 28. And then I'm going to divide by 12 and reduce. So out of this first term, I have a GCF of 3, so this I can factor as 3 times 4v plus 1. And here I have a GCF of 4, so I could factor that as 3v minus 7. And then 12, I can write as 3 times 4 to reduce this 3 down to 1 and reduce this 4 down to 1. So my final factored form would be 4v plus 1 times 3v minus 7.